Now let's turn our attention to part C and D. Write an equation for the line tangent to the graph of h at x equals 4. So these words here, equation for the line, immediately I'm thinking, okay, I need a point. For part C, I need a point and I need a slope. For the point, for the equation of the line, I'll use x equals 4. And I need a y value. Well, I can't plug it in here because that's the derivative. That will give me the slope at 4. I want the actual point. Luckily, they've given it to me here. So if they haven't given you the h of x function to plug it into, then they must have given you the point somewhere. And indeed, our y value will be -3. Okay, so that's our point. Now our slope, we'll deal with the derivative. And we want to find specifically the slope at x equals 4. Plugging in 4 to our derivative function, I get 4 squared minus 2 all over 4. That's 16 minus 2 over 4, which simplifies down to 7/2. So that's my point. And here I now have my slope. Let's plug them into our equation for a line. Y minus y1 equals mx minus x1. So I have y minus -3, or y plus 3, equals my slope is 7/2, x minus 4. And we're done. Let's do part D. So part D says, does the equation of the line tangent to the graph of h at x equals 4 lie above or below the graph of h for x values that are greater than 4? So what does that mean? Basically, what it's getting at here is, let's call this our graph h. And at x equals 4, we wrote the equation for the tangent line. So let's say we came up with this line here. What they're asking us is, does the line that we came up with, which I'll demarcate in blue, does that line lie above or below the actual graph of h for values beyond 4? And based on my drawing, it lies below. But if my graph had looked like this, for instance, then it would be lying above. So the key to figuring out whether the estimate that you've made, the tangent line that you've come up with, if it lies above or below the actual graph, is this. So write down in your notes. If f of x is concave up, so imagine we have a graph that's concave up, then the tangent line at any point will be below the curve because the graph is cupping up and away from that line. So again, if f of x is concave up, another way of thinking of that is if f double prime is positive, then the tangent line will lie below. On the other hand, if we have something that's concave down, notice what happens to the tangent lines now. Any tangent line will be above the graph. In all cases, right? My graph is curving away in the negative direction because it's cupped down. So if f is concave down or the second derivative is negative, both of those meaning the same thing, then we say the tangent line lies below. So based on that information, we need to deal with the second derivative and determine, is h concave up or down? So from part B earlier, we already found the second derivative. And we made a number line, which I'll recreate here. We had a 0 of 0, and then our signs are plus and plus. So we can see from this graph that it was definitely concave up for x values that are 4 or more. In fact, it was concave up everywhere, if you recall from part B. So since our graph is concave up, facing like this, draw a quick sketch and realize that our curve will be below, or our tangent line will be below the curve h of x. So let's write our final answer. Since h of x is concave up for x values greater than 4, the tangent line lies below the curve. Okay, so let's compare our work against the AP rubric. So for part C, you can see it was worth just 1 point for getting the tangent line equation, which matches what we got up here, y plus 3 equals 7 halves, x minus 4. That was a simple plug-in problem. And then for part D, also 1 point for having the answer, which is that it's below, with the reason. So without a reason, you won't get the points. You can't just guess, oh, above, below. You have to explain h is concave up. And how did we know that? Well, we used the justification from our previous number line. Okay, I hope that video was helpful. You can find more problems like this in this section called Analyzing Graphs, Relative Extrema, and Concavity.